Hello everyone, this is Sridhar, Assistant Professor in Mathematics, Marri Reddy Institute of Technology and Management. The subject name is DEVC, Differential Equations and Vector Calculus. In that, the topic will be ordinary differential equations of higher order. Today, we are going to discuss a type 4 model of functions. In this, we are going to find the PI, particular integral, for type 4 type of model functions. Those are in the form of, that will be q of x equals to a power of ax into v of x. So here v of x may be one of the previous type of functions. It is like either trigonometric function sin bx or cos bx, or else any polynomial function of degree m. Right? So what is the working rule to find a PI? That is called particular integral for this type of functions, e power of ax into v of x. So let's start studying the working rule. So here v of x is one of the previous type of function. Then what is the working rule here? Let's see. PI is 1 by f of d into e power of ax into v of x. In e power of ax into v of x, here we need to shift e power of ax outside. Okay. So shift e power of ax outside while replacing d by d plus a. So that here e power of ax shifted outside. Now here d will be replacing by d plus a. Right? And the remaining will be v of x. Okay, next what? Now you can proceed. According to the function v of x, whether it may be type 2 model function or type 3 model function. Based on that, we can proceed. Because already we know the working rules, how to find PI for type 2 model functions and type 3 model functions. Right? Okay, now let's see. Example based on this. Right, this is an example. So our example here, solve d square y by dx square minus 6 into dy by dx plus 13y equals to 8 e power of 3x into sine 2x. So this is a second order differential equation. Okay, what is the general solution for this equation? The general solution is given by y equal to cf plus pi, a complementary function plus particular integral. As already we know, your complementary function is to be found for the left side part of the differential equation, and pi, that is the particular integral, to be found for the right side part of the differential equation. Now let's start finding one by one. So first we need to find a complementary function. Okay, for that I will write. So here the second order, d square y by dx square. I am writing the equation. That is the given differential equation is d square minus 6 into d plus 13 into y equals to 8 into e power of 3x into sine 2x. So given differential equation, this I am writing in form of differential operator form. Now this one I am taking this f of d into y equals to 8 into e power 3x into sine 2x. Comparing with both of them, then where f of d equals to d square minus 6d plus 13. Now take the auxiliary equation AE. The auxiliary equation is f of m equals to 0. That implies m square minus 6 into m plus 13 equals to 0. Now this will be the quadratic equation. Now we need to solve this quadratic equation so that we get the two roots. Okay. So we are going to solve the equation m equals to minus of minus 6 plus or minus square root of minus 6 whole square minus 4 into 1 into 13 by 2 into 1. Okay, that will be in the form of, that is, x is equal to minus b plus or minus square root of b square minus 4ac by 2a formula. Right? Using this formula, here I am going to write like this. Now, simplifying this, minus of minus 6 means plus 6 plus or minus square root of minus 6 whole square means 36 minus 4 into 1, 4, and 4 into 13. 4 into 4, 52 by 2. Right. Next, equals to 6 plus or minus square root of, okay, 52 minus 36 will be 16 minus 16 by 2. And this is equal to 6 plus or minus square root of minus means there will be a complex root I, and the square root of 16 means plus by 2. Now in the numerator 2 take out common and cancel them. The remaining will be 3 plus or minus I2. That will be a complex root. Complex root in the form of alpha plus or minus I beta. And comparing with this, whereas alpha equals to 3 and beta equals to 2. So whenever the roots will be complex roots, then how to write the complementary function? That is CF is yc equals to a power of alpha x means 3x into c1 cos beta. What is the beta value? 2. So cos 2x plus c2 sin 2x. This is our required complementary function for the differential equation. Next, we need to find the PI, particular integral, for the right side part of the differential equation. So in the next page, now here we are going to find PI. First start with 1 by f of d into whatever the right side function that we need to write here. What is the right side function here? 8 e power of 3x into sine 2x. So 8 e power of 3x into sine 2x. Okay, here 8 is already constant, writing outside. 1 by f of d. What is f of d? D square minus 6d plus 13 minus 6d plus 13 into e power of 3x into sine 2x. Here we can observe this will be in the form of e power of ax into v of x form. Means this belongs to type 4 model functions. Okay, type 4 model functions. For the type 4 model functions, we know the working rule. In that, here we need to shift the exponential term outside while replacing d by d plus a. So here I am shifting the exponential term outside, that is e power of 3x shifting outside, while d replacing by d plus 3. So here d replacing by d plus 3, that is whole square, minus 6 into d plus 3 and plus 13. Sorry, this is 13. And into remaining will be sine 2x. Now simplify here. 8 e power of 3x into 1 by, now simplify this, d square plus 6d plus 9 minus 6d minus 18 plus 13 into sine 2x plus 6d minus 6d cancels. Now here 9 plus 13, 22. 22 minus 18, 4. So here the remaining will be 8 into e power of 3x into 1 by d square plus 4 into sine 2x. So here all simplifications are completed. So remaining is this. Now in this case, we observe here sine 2x that belongs to type 2 model function. Sine 2x that belongs to type 2 model. In type 2, what is the working rule? Just follow the working rule. So according to the working rule, here we can write this value will be 8 e power of 3x into x into f dash, or the denominator derivative 1 by 2d into sine 2x. Or else you may use the formula that will be like 1 by d square plus a square into sine ax. Its formula directly can write minus x by 2 into a into cos ax. You can use this formula, so you can write directly value. Why? Because here the denominator you may get 0. D square is replacing by minus a square. On replacing this d square by minus a square, denominator will get 0. So that you can use this formula, right? So using that formula, so that what will get minus x by 2 into a, that is the value 2 into cos 2x, right? Next, on simplifying, 2 into 2, 4, 4 1 ja, 4 2 ja. So that equals to 2 e power of 3x into x into cos 2x. Finally, this is equals to 2x e power of 3x into cos 2x. This is our required pi. So after finding the pi, the next step, general solution. Therefore, the general solution of 1 is y equals to cf plus pi. So already we found cf. What is cf here? This one. Y equals to yc complementary function, yc equals to e power 3x into c1 cos 2x plus c2 sin 2x. E power of 3x into c1 cos 2x plus c2 sin 2x and plus pi, that is plus 2x e power of 3x into cos 2x. That's it. This is our required solution. Is the required solution, where c1 and c2 are arbitrary constants. Okay. Next, one more example based on the same concept. So here the given differential equation is d square plus 4 into y equals to e power of x into cos x. Right. Again, this is second order differential equation. Here also the general solution will be y equals to cf plus pi. Here the cf will be the complementary function, that is we need to find for the left side part of the differential equation, and pi will be the particular integral, that is a solution to be found for the right side part of the differential equation. Okay, now let's start finding the complementary function and then find cf. Okay, let's start the solution. Given differential equation is d square plus 2 into y equals to e power of x into cos x. Now let's take f of d into y equals to e power of x into cos x, where f of d equals to d square plus 2. Then take the auxiliary equation f of m equals to 0. This implies m square plus 2 equals to 0. Therefore, okay, m square equals to minus 2. Then m equals to plus or minus square root of minus 2 equals to plus or minus I into root 2. So the roots are complex roots. So these are the complex roots. Here the complex roots are in the form of alpha plus r minus I beta. Comparing this, whereas alpha equals to 0, beta equals to square root of 2. So complementary function is given by, that is yc equals to e power of alpha x. E power alpha means 0. So e power 0 means 1. So remove directly. I am writing the c1 into cos beta means root 2x plus c2 sin beta means root 2x. So this is our required complementary function for the differential equation. Okay, next we need to find the pi, particular integral. Okay, let's start by finding the particular integral. So pi, that's 1 by f of d into e power of x into cos x. 1 by f of d, that is 1 by d square plus 2 into e power of x into cos x. Here we can observe this part will be in the form of type 4 model function. Okay, and we know already type 4 model function working rule. In this, we need to shift the exponential term outside while replacing d by d plus a. That means here d plus 1. So e power of x is shifting outside, and now I am replacing d by d plus 1 whole square plus 2 into cos x. Here what I am doing, d replacing by d plus 1. Now simplify it. 1 by d plus 1 whole square means d square plus 2d plus 1 plus 2 means 3 into cos x. Right. After simplification, remaining is, here we have the function is cos x. And here remember, cos x will be the type 2 model function. Now here we need to proceed type 2 model working rule. What is the type 2 model working rule? In type 2 model working rule, first of all, we need to replace the denominator d square by minus b square. Here b value means x coefficient, that will be 1. So e power of x into 1 by minus 1 square plus 2d plus 3 into cos x. Here d square is replacing by minus 1 square according to the working rule of type 2 model functions. So equals to e power of x into 1 by, it becomes 2d plus minus 1 square means minus 1 plus d plus 2 into cos x. Now again here, the denominator that contain only d. Again d we need to rewrite in terms of d square. For that we need to multiply and divide with its conjugate. So first of all here I am taking the common, by 2 taking common. Then the remaining is 1 by d plus 1. Now here I am multiplying and dividing by its conjugate d minus 1 into cos x. And next this is equal to e power of x by 2. Numerator becomes d minus 1 by denominator becomes d square minus 1 into cos x. Now again here in the denominator we have the term d square. Now again d square is replacing by minus 1 square. So e power of x by 2 d minus 1 by minus 1 square minus 1 into cos x. Here since d square is replacing by minus 1 square according to the working rule. And finally the denominator becomes minus 2. Minus 2 also writing outside becomes minus e power of x by 4. The remaining is d minus 1 into cos x. Now multiply the numerator d minus 1 into cos x minus e power of x by 4 into d into cos. D means, we already know, d means derivative. That means the derivative of cos x minus 1 into cos x. So minus e power of x by 4 into, now the derivative of cos sin x minus cos x. That's it. This is our required particular integral. After finding a particular integral, now general solution. Therefore, the general solution of 1 is y equals to CF plus PI. That CF will be C1 into, 1 minute, C1 cos root 2x plus C2 sin root 2x. C1 cos root 2 into x plus C2 sin root 2 into x. Now plus PI. What is the PI? This minus a power of x by 4 into sin x minus cos x minus e power of x by 4 into sin x minus cos x. Sin x minus cos x is our required solution. Right? Is the required solution. Where C1 and C2 are arbitrary constants. C1 and C2 are arbitrary constants. Okay, right.